It is live. Whatever.
We are live.
Okay. So, how should I just introduce this mess? What did I do? All right. Basically, cache readers and cache writers. Right? So they're. Maybe I'm naively thinking about this, but the way I think about this is that the reason they're there is to facilitate the cache through pattern. I don't think there is any other real reason to have the...
There's no other reason to have them so tightly integrated.
The writers, certainly, I mean.
Yes.
Because the loaders, you could say, right, they can be useful to warm the thing up. They're
still going to be talking to a system of record or somewhere that the thing that you're caching.
Yeah, right. But
you've got to pull from somewhere.
But no, yeah, they do. But what I was trying to say is, right, this is, I think, the one reason why we have async cache, bootstrap cache loaders or whatnot, right? So
yeah,
you
but
start up a cache application can go live, and it won't wait for your app to warm the cache up. It will actually warm the cache up.
But bootstrap cache loaders are a really separate thing, I think.
Right, in terms of API, I think they remain the same thing. It's a way to do both.
That might be coincidental.
Okay.
I think that as far as I'm concerned, right, they serve different purposes.
Oh no,
yeah, they are different things.
Right. Okay. So
let's say collections both have sizes.
So what is the use case for having a cache with only a loader or a cache with only a writer?
A cache with only a loader, to me, there's only two reasons you'd do it. One is you're explicitly caching something that you're declaring is read-only, or so rarely written that you are prepared to invalidate the entire cache when you write to it. Or you've decided to implement some kind of bizarre hybrid cache through cache aside combination where you do the reads through cache through and the writes through cache aside.
Right.
And I think the first one makes sense, and the second one is insane.
Maybe not. If you want to do that, the simply invalidate the entry. Right. So basically, you do, I guess.
Yeah. If you can accommodate temporary stale reads, it works. And also, I think a justification for using it is you have synchronization, and what you find, the cache offers implicit synchronization in the context.
But what you're doing at that point, right, is accepting inconsistency in some places and not in others, and you're basically causing yourself to incur costs you don't need to. The cache load, let's make no mistake, cache through is going to be more expensive than cache aside because it gives you more. When you do cache aside, there's this inherent race. You read the thing, and then you read the thing unless you stick in like some kind of transaction manager or external locking around the cache and system of record. You read the thing, and then you race with everyone else who may have read the thing to put shit into the cache. So if you
that's what I was kind of hinting to. So
so
you do get, right? You get the value. If it's not there, it's going to be read from the data source. Then when you do an update on the side, right? Commit your and invalidate from the cache, and then whenever it's needed, again, it's going to be reloaded. So you
but it's broken because what if somebody else reads the note, you go to write to the system of record. Somebody else has read from it before you. You go to invalidate the cache, and then the read gets ordered after that. You're racing with other people who may have read before you wrote. Your cache isn't safe.
No, because you're thinking about a pattern where what you read is used to decide what you write.
Yeah.
But just take it in a different consideration. You're reading some kind of reference data that, like you've said yourself, is rarely updated. And then a different business process goes and updates it.
Yeah.
Right.
Weather forecast.
And you blow it away. I know, it just...
Right. So that's the one. So anyways, I can totally see where that makes sense. Can we think about the other case though? No loader, but a writer. This one confuses the crap out of me.
Okay. I can only think of, I mean, you can derive really contorted cases where you have a system that has an extremely high write rate
Mm-hmm.
and is extremely expensive to read from. And so you basically say, even then it doesn't make any sense.
Does that exist?
I mean, the only other reason would be that you're using the CacheWriter as some form of secondary auditing. You're normally cache aside, but the CacheWriter is connected to some auditing process. But why you would do that way and not connect it to the system of record and audit there, right. I don't know. It would make no sense.
I don't get it.
This way, I can't think of any sensible topologies, but I guarantee you someone will have done it.
Right. Okay. Yeah. But that's a different problem. Okay.
But
so
here's the thing. Yeah. We talked about tying the two together. To my mind, neither of the use cases we've talked about precludes you from having a cache reader that returns null all the time, or a cache
no.
cache writer that.
So that's what I'm getting at, because
the common case is
Louis didn't get any of the background on this. So my take is I want to get rid of cache loaders and cache writers, and I want to have the sum of the two, or some of the two, because I think what we have now is not really useful.
The cache through.
Right, and whatever it is, but fundamentally it's an enabler for implementing the cache through pattern properly, right? So as Chris said, if you have a use case for only doing load, and so if I still conflate the cache bootstrap loader thing in there, I think it makes sense to have a single thing for that, but that's not really relevant. The bit is that I want to have this interface, this single thing that somebody implements, and that basically makes sure that whatever method you called on the cache, it's going to do the proper thing.
Well, it's
to the system of record.
Yeah.
Okay?
I mean, it's guiding people. The whole point here is that we think that the common use case is if you use a cache loader, you probably want a cache writer as well. We're not forcing you to have a cache writer, but we're saying you are strongly encouraged to think about whether or not you need a cache writer too. Vice versa, right. you go, I want a cache writer. Oh, maybe I should have a cache writer too. And the interface, if you merge it to it, it naturally forces you to realize that. What do you think about it?
And if we do that, would you consider giving away, since we find the motivation for the cache reader only, for the cache loader only side, and maybe not the other one, would you consider giving away a default implementation of that interface that would do no op?
Depending on what we come up with. But here is the one bit that really puzzles me. And I did implement this in the 107 wrapper, but I don't remember what I did. So here's the take. So there are concurrent operations, atomic operations on the cache, right? So what's a putIfAbsent if you have a cache loader and a cache writer, right? I guess you go hit the underlying thing, and you make sure that there is nothing there.
If it's a cache loader, cache writer, the operations on the cache are not really operations on the cache, are they?
No, that's my take. And then when you start thinking about replaces and stuff like that, right? And again, the reason probably you would use any of this is because I think I like the 2arg remove. I think this one's kind of fun. So the 2arg remove, basically, when you invoke that, in my books, what you're saying is I want to delete this only if the state that you currently have matches the one that I'm proposing you, right? So how do you do this with a cache loader and a cache? So what would this even mean if you, for instance, had a cache loader and no cache writer? Do you hit the system do you load to then only remove from the cache the thing that wasn't there to begin with? And does it even matter that you reply true or false on this, whether the remove actually succeeded or not? If it's not in the cache, could you not always say yes, it succeeded?
Well, so to me, I kind of try and think about.
And then if there is a writer, does that mean that you load the darn thing in memory just to delete it from disk again? Or do you tie the whole delete this value from the system of record contract. Oh crap! So, fuck, what was it? Delete this value from the system of record only if it like obeys the equals contract or if something else happened. So the one example that I took is the one way you would make this work and be performant is through an optimistic locking strategy of some kind. But version the things, and then the way you don't need to load. The only thing you can do is basically, oh, you're asking me to delete customer foo, but what you're giving me is the primary key. And in the value, I also have the timestamp to which it matches. So what I can do is I can straight delegate to the writer and say delete where ID equals n and timestamp or incremented thing equals this value. And if this succeeds, it means that the remove succeeded. Right? It makes no sense to you're a cache. The whole point is to make this fly. Why would you load the entire thing in memory from a system of record to delete it back again in a very inefficient way? I think we should be able to
I think you need to split the two. You need to split the correctness and the semantic of the operation from making it performant.
No, this is a cache. Its whole purpose is to be performant.
So here's my thing. I think I'm not sure what Louis is driving at, but the cache loader is a device, is a thing that allows you to ask the system of record or whatever, the data source that we are caching, what is the correct thing currently that should be cached to this key. Just because we have one doesn't mean we have to use it. And the only and like Alex said, the whole point here is performance. If it makes sense to use it, use it. If it doesn't, don't. So if somebody, to me, the whole point, if the point of this cache foo thing, that's the merger of reader and writer, the whole point is to enable cache through as a pattern, then when somebody, like I said, when somebody does a 2arg remove, they are asking to do a 2arg remove on the system of record because it's cache through. Anything you do on the cache is actually a request to do it on the system of record, and you're just doing it through the cache so the cache can do the right thing to make the system work. That was my child's doing something bad, look. I was about to jump off a high edge.
I agree with that, and I think that's what I was trying to say.
Right, cool. Then if you don't need, if calling the cache loader doesn't help accelerate the process, don't call the cache loader.
That's exactly what I was trying to say. So what we should look at is, I'm the user, I have my cache through, I do the remove. What's the net result I want?
Right. But here's the thing.
And then what we do internally to make it work and make it performant, like skipping the loader, like not even checking the state of the cache, but sending directly to the database and to the writer, etc.
So the writer,
these are things that in fact the API log.
Yes,
right?
yes. The writer. Here's my thing. The writer the cache writer or the writer portion of the thing should expose the same mutative methods or have on it mutative methods that map to the mutative methods that are available on cache. I say that in a vague way because I'm not saying it has to strictly be one-to-one, but every mutative method every mutative operation you can perform the cache must have some equivalent mutative operation that happens on the writer, which is to say, we did a 2arg remove, we did a replace, we did that, we did the other. Okay, and the job of the writer is simply to do that equivalent operation on the system of record. Now, whether or not we choose to call the cache loader is an implementation concern. It's not something that the writer should have to understand or think about.
I think, I fear this might not be correct. I think I want to go and write.
We can do what we want.
Basically, you want the transparency of whether the data was in the cache or not, right? So again, this is what so 3arg replace or
the equivalent would be you call get right? On a cache through cache. You know that it's either going to return from the cache or call the loader. You trust if it returns from the cache that it's doing so sensibly. Per the way you've configured, that it is correctly invalidating when you do writes and shit like that. You trust that the cache will return the correct thing. If it's not in the cache, say, and your cache reader gets called, and you say, "Oh, you called the cache reader. Okay, well, all I'm going to do is blindly do what you tell me. Go and find out what the correct value is for this key. Return it back." The cache doesn't have to cache that. That's an implementation concern. If we decided for whatever bizarre reason, we think that this key is of such questionable value, the way this thing's configured, we've decided that this key will never be hit again, therefore I'm not going to bother to cache it because there's far more important things in this cache. Tough. You still return it. It's blind to the user. It's the same thing on the write path. The write path could go tunnel straight through and call straight through the CacheWriter and not touch the cache. What the cache does is the cache's business. It's exactly the same as like resource management. You have to trust the cache to do the right thing, and right implies in two dimensions. Right in terms of consistency,
right,
and right in terms of performance.
Yeah, but there is this obvious thing where, so again, if you do the to-arg remove, right, where if the thing is in the cache, it's obviously, like from a performance perspective, it's obviously going to be way quicker to compare against that.
Yep.
If it's not in the cache, it's probably is. Well, I can easily think of ways to implement this, so it's way quicker to let the writer do it all instead of even falling back to the load.
You think logically it's always at least as cheap, if not cheaper, to just let the writer do it.
How is that an issue?
I'm not saying that anything's an issue.
Okay,
We're doing a pretty. There is quite a shift that we're proposing here, and it's stuff that basically we need to rethink exactly what then the APIs for this start looking like.
I think this all makes sense. Here's the thing I worry about. If you call to-arg remove with a key and a value, and it is cached, and you do the value comparison, and it is equal, and you say the remove succeeded, you clear it from the cache. You then call down to the writer and say, here's my to-arg remove key and value, and the writer says it didn't succeed. That's where you want to worry. What do you do then?
Why do you have to do anything? The user won't see the difference. Yes, it's no longer in the cache, but next time he hits it, he will get the value from the database.
But it implies that something was broken before, potentially, depending on whether the user is expecting it or not.
Okay, so that's why
we were caching value that was wrong.
Yeah, but that's what I'm saying. That's why I said we want to look at the correctness of the operation before the optimization we need to do to make it performant.
Right, but
so
that
we need to have a look at these different.
Wait. What are we right? Because I think I touched upon that with Chris slightly earlier, right? So if you consider that the cache acts as a locking mechanism, so that all those things are delegated properly, it should always be fine. Now, there is one very obvious case where everything falls apart, is that if people go fiddle in the database directly, which people do. So, what does
then how is that an issue? You've had the entry in the cache.
Well, you can be resilient.
This is the discussion we had.
But wait. The use case Chris gave is not a problem. You've the entry in the cache. You've the to-arg remove. It's a match. You remove it from the cache. You go to the database says fail. Who cares? Next time the user tries to read the value, he will read the value that's in the database.
Totally.
And you return false.
However, the opposite is an issue. If we manage to get out of sync, and that the entry you have in the cache is wrong, and so you refuse the remove at that level.
Right, and then you do the to-arg remove on the writer.
Does it mean?
No, you don't pass it through in this case, right?
Yeah, you don't pass it through.
If it failed at the cache level,
this is
you don't want to get to the writer.
Right, but this is why in the meeting we had earlier, which unfortunately wasn't broadcast or recorded, I suggested that there were two modes. There was you have to tell the cache loader writer system. Two ways of phrasing this. Either the cache is always consistent, or the cache isn't always consistent. Alternatively, you can phrase it as, I do backside mutations of the database, or I don't.
No, and I think we shouldn't cover that case.
Yeah,
I think what we offer is a consistent cache. If you do backside mutations, you're on your own.
Yeah.
Right, but here's the thing, right? If you don't, but if you don't do backside mutations, then you can do the to-arg remove on the cache and say, if it succeeds, I know that I am consistent with the system of record. But so therefore, I can do a one-arg remove on the system of record, which might be cheaper.
No, that's not even true. You can't do that because the remove could happen as the first operation on that key. Nobody said that you had to do a read before you could do a remove.
Right, but then it's not in a cache, and so I just fall through to a 2-arg remove.
Yeah, then
I'm saying if it's cached, and I'm guaranteed that it's consistent, then I can do the comparison, and assuming that nobody's screwed up the equals contract between the writer and the POJO, then I can do the value comparison, say it's true, remove it, and say, since I know I'm perfectly consistent with the system of record, I can do a cheaper 1-arg remove on the system of record now, rather than having to do the same equals comparison, which I know is guaranteed to pass.
Okay. What would be the value for us of implementing it that way? Why don't we? No, it's not faster. Not for us. It's not us doing the job.
No, for us it's
the writer.
And I can again implement it in such a way that it's as fast.
We should always pass all the arguments to the writer, and then it's the writer deciding. And since it's the guy implementing the writer, he knows if the cache is completely consistent or not.
What do you mean you can make it just as fast, Alex? Sorry.
Oh, because most probably I can push data to the database without increasing any packets going over the network, for instance. The optimistic locking thing is just going to cut it fine.
Oh, it's no. That's true if there's no contention, but if you're doing tons of 2-arg removes, all in contending with it, if there's lots of traffic going on, I don't care how clever your optimistic locking is, at some point it's going to break down and start failing and rolling back, and then it will...
Okay.
Wait,
no.
but that's inside
the writer. It's
writer.
always going to be faster if you push it hard enough to do a single arg remove.
Where?
On the system of record.
Okay, but that's the implementation of the writer. It's not us. It's outside. It's user code. So they get to be the one to decide.
But Chris has a point.
The user code. It's still the same system. We're not blind. I mean, you can't blindly use the cache and say screw these up. The user's cache thing.
Louis, if you agree with Chris's point, the writer needs to know that there's been an equals comparison that's exceeded at the cache level as you get the write. Which I'm not saying is a bad idea, right? You could totally have that. But you need that additional piece of information provided to the writer. The writer can't do anything smart about that.
But what I'm saying is that I would not call the writer with a single arg remove. And I would call the writer with all the args and let the writer decide if he has to do a single arg remove.
That's fine. I have an objection to that. I'm just making a statement that is, performance-wise, that is slightly suboptimal.
Why? That's what I don't get.
Because any sanely implemented system of record is going to be slightly slower under extreme circumstances, under load, doing a 2-arg remove than doing a 1-arg remove.
You're not. So I have the cache.
Mm-hmm.
I do the comparison.
Right. Comparison
succeeds.
Yep.
I send that information, including all the arguments of the initial.
No, then you're effectively what? Right. So then you're saying, tell it I did a 2-arg remove, but also tell it that I succeeded. That's what.
That's what I was saying.
You've now got a 3-arg remove, which is key value, and true or false. Did my value comparison succeed?
Yes, but I have it on the writer only, which is an API dedicated to the user.
Yeah, and as I said, I'm not saying it's a bad idea. It could be a good idea.
Then the user, in its implementation, can decide
whether
or not what the cache said is reliable enough so that he can move to a single arg remove.
Yeah, that's fine.
That is mutating the data store underneath. Then he knows he can't do that, and he still has to do the 2-arg remove.
And so again, this thing.
What's the performance loss in that bit?
There isn't, but I thought you were describing a scenario where you didn't. What you're describing is basically saying, I don't know if you can eliminate the 2-arg remove and go to 1. I'll let the user decide. I'm saying that if the thing is always perfectly consistent and the equals contracts align between the POJO and the database, whatever it is.
But the perfectly consistent is not an information we own.
Well, I suggested that you could know that by asking the user to configure it.
No, because the user. It's probably going to be the same, but.
The user should know, because the user should know if the user comes back.
You know what? I'm actually going to create again like a spike thing, and I'm actually going to go through the entire pane of not trying to spike the API really, but to really like implement all this and see what I end up with. Because I think there's also this case where all of a sudden such a delete, for instance, would actually need to return a value.
Yeah,
which again, it's fine, right? It says, "Oh, I couldn't delete," and you told me it was correct. For you just drop the thing on the floor, and then you return the appropriate return value to the user. But at least you also, again, were resilient in the sense that, oh, I got out of sync. I realized this. I'm going to
blew the cache away,
and I'm going to let everything heal.
What I'm angling towards at the moment, I think, is the same starting point for this is the one-to-one correspondence between mutative operation and writer thing. So you do a 2-arg remove in the cache. There's something that says do this 2-arg remove on the
then factors from there,
and the return value from there. And the cache, in response to seeing a clash, the resilient cache goes, shit, I did the 2-arg remove and it failed, and they did it and it passed, or whatever. Always check. Always check.
No, the always I don't agree with. I'm not.
Well, you're saying if it fails, you'd rather not do it.
If only if it succeeded for us, we let it go through. If it didn't for us, it means that indeed the guy is doing funky shit and informs the other side, both ends of the cache, by the way, right?
Yeah.
Oh, here is the newest value, and here underneath the newest value, given there is no bug in our stuff, why would you?
No, so when you see a clash, you drop the cache, like you said. But the other thing is, I think you can report it to the strategy, the resilient strategy.
Oh, that could be another thing where maybe
to say I saw inconsistency here. I've tried to heal by dropping the cache, but you better realize that this is happening because this isn't good.
Yeah.
I mean, it's fine if you know it's happening because you may be planning for it. But if you're not planning for it and that's happening, that implies something weird is going on.
And yeah, I think, Alex, even when it fails in the cache, you should still send the operation through.
No, that makes no sense. You're again killing the whole cache idea. The whole reason in the fine-tuned system, the whole reason you want to have this thing in is to never hit the system. It could be amazing. It may actually cost a lot of money.
If that's sensible, what if I do a put? Is the cache allowed to do a dot equals between the two things?
If I do a put, is it a dot equals?
Is it allowed to make some kind of comparison between the thing that's in the cache and the thing that's just being put and say those two things are the same?
Well, in this case, I would say no because you don't know. And the writer can know. That's the good thing.
I didn't know. You don't know what equals means.
I think that's also why I think
it's the domain of the user, and the writer is also the domain of the user.
But isn't that the same argument? Can't you apply the same argument for the remove? You're assuming the main object.
No, the remove with multiple arguments. You assume that the user expects you to understand the contract. So I can see the difference. But still, let's see. But if the idea is really to implement I guess we need to choose whether or not we have a strategy which is inconsistent cache through. If we support that, we have to support it everywhere. And if we say no, when it's cache through, we only support fully consistent, then it's going to allow us to do a number of simplifications.
Yeah.
But otherwise, there is no in-between for me. It's either we're only supporting consistent, but if we support inconsistent, then something like the remove to arg, if it fails in the cache, you can't stop there. You need to send it to the writer, and then the user code in the writer can optimize by not sending it to the database. But it's no longer our responsibility.
That is nonsense. Sorry, but you're just arguing for throwing the whole reason of a cache to exist out of the window and say, oh.
No, that's not what I'm saying. I'm saying whether or not we accept to support a cache through in a non-consistent way. And the answer can be no, we don't accept that.
The problem is you're a cache. This is the whole reason why we're doing the resilience of it. I think I'm going to code this. I'll be done probably by the end of the week, and you guys can then.
It's kind of what Lily's talking about. It's kind of akin to basically just throwing the cache value or cache away on every mutation, not the whole cache, but the cache for a key away on every mutation of that key. It's not the most efficient way of caching, but I don't think it's fair to say that it's throwing away all benefits of the cache. That's not true.
All right.
It will get repopulated on the read, and it might get read multiple times, in which case you are getting benefit. You're just potentially not getting as much benefit as you could do.
Right. I'm gonna aim for the much benefit as you can.
And again, you're getting into that situation because you want to do cache through and mutate your system of records in a different way. So it's your responsibility for doing that.
I mean, for me, I think the key thing here is to figure out what the common use case is. It's the whole.
And actually, maybe I'm actually changing my mind, and well, not changing my mind. Actually, saying that yes, we're actually deciding that what this means is that we only go for full consistency. And when stuff goes wrong, instead of trying to like give the return value back, for instance, or something like that, the guy actually throws an exception. Because that's one that we need to deal with. We have to deal with anyways, right? At some point, a write's going to happen. We're going to mutate the cache or whatnot properly, and then the underlying thing is going to throw some exception. We'll have to deal with it. And that could be on a replace that works perfectly fine from our perspective, but then violates constraints in the relational database, right?
Yep.
You won't be able to deal with that. So, and people tend to not model their constraints in their domain model, but in their databases, right? So we'll have to deal with that anyways. So actually, maybe that's good enough. Talking about the return value on a replace, for instance, right? If we say the replace, if we tell the writer up from on our side the replace succeeded, and then he tries to do the replace on E saying it doesn't succeed for him, he doesn't return false. He throws an exception, any kind of exception that he wants, right? It's going to get caught by the cache. It's going to do its cleanup that it needs to do, and in turn, it's going to throw a CacheWriter exception in this case, right? That he can handle. So yeah, you don't see it, but I did all that for the cache loaders. So now when a loader throws an exception, it gets dropped into an exception runtime that the user can deal with higher up if he wants to. And then if you're in a situation where you know that you deal with that and it's fine for you, it's pretty easy for you to write a wrapper around your cache that will just catch those CacheWriter exceptions, make sure that they're, I don't know, Aura-1654 thing, and then that's fine, I know what that is. And I know the cache sort of doesn't hold a stale copy, doesn't hold no copy anymore, right? We just try to clean our stuff up, and you happily keep on doing whatever you were doing.
Yep.
So actually, I think I changed my mind. You don't need the writer. You can build on the fact that the writer will succeed, and in case it doesn't, it's not panic mode, but close to it. But
it's not panic mode, but I think it warrants the strategy thing we were talking about, because it's like an exception. It's not panic, but it's certainly beyond the reach of the cache. It's beyond the understanding of the cache to know what to do.
Tell us what to do.
We need the user to decide: is this has the shit hit the fan, or is everything fine?
We could handle this with an exception handler at the cache level, a cache through integration exception handler.
Yes, something like that.
And it can do whatever it wants, right? It gets notified if it wants to swallow the exception.
Yep.
My guess.
Go on, write it all up, and we'll tell you how it's wrong.
Okay, so what I'm going to do, I think I might put more work on my plate than what I wanted. So I got two options. Either I do a spike, or I just take this whole thing on my plate and I just go about and do it. I think I might be better off.
You might as well start doing it, and you can always just go back and decide that. What's the difference? Plan, do it to the best of your abilities, and we'll figure it out. If we think it looks good, we may as well reintegrate it. If it doesn't, we won't.
Right.
There's no need to decide ahead of time that you're going to...
No, I was just wondering whether I should move the implement CacheWriter cache loader stuff and assign it to me.
You should at least assign it to yourself, just in case somebody picks it up.
Yeah, so I'm not going to make it really in progress. I'm going to leave it in the backlog, but it's assigned to me.
At least that way, nobody's going to take it and waste time.
Yeah, and I'm going to send an email to the mailing list with probably a link to all the madness we discussed here.
Sweet.
It looks like we got one viewer. Whatever that is. Can just react to this. I think this is...
Q&A work? Maybe they can...
I'll do that, okay?
They haven't asked a question, so they obviously think everything's great.
No question.
Okay.
Answers. This is madness. This will go south. No way this.
The best ideas do.
Yeah, because this all like I need to do a bunch of changes to store, the whole putIfAbsent stuff and whatnot that needs to be there in order to have the proper locking in place. Because otherwise, how do I do atomic operations like the ones we're talking about? I can't right now. So there. Yep. I knew this work was coming up, but yeah. Okay. Oh well. Cool.
And if we merge the two concepts, is that not an issue with regards to 107?
No.
No, because we can write glue
If you just specify a loader, then we wrap it in a skin that just talks to the loader and then writes it in. Oh, so you specify writer, it does reverse. You specify both, it does both.
Yeah. Okay.